Good morning, everybody. I am Dr. Shanti M. George, Associate Professor, RMK Engineering College. In this video, I would like to explain about the components and principle of laser, mainly the resonant cavity and optical amplification. The main components of a laser are first an active medium, a pumping source, and an optical resonator. An active medium is the material in which laser action takes place. It may be a solid or liquid or gas. Pumping source is a device by which population inversion is achieved in the active medium. An optical resonator has two parallel mirrors. One is a perfect reflector and the other is a partial reflector. Optical resonator or resonant cavity. An optical resonator consists of a pair of reflecting surfaces in which one is fully reflecting M1 and the other is partially reflecting M2. Optical resonator helps to further intensify and amplify the radiations. For sustained and amplified output radiation, a part of the output energy should be fed back into the system. This is achieved by keeping the active material in the resonating cavity, which can be as simple as a pair of mirrors. The photons generated by laser transitions between energy states of active material are bounced back and forth between two reflecting surfaces. This will induce more and more stimulated transitions leading to laser action. In this diagram, the M1 is the fully reflecting mirror and M2 is the partially reflecting mirror. So the photons are reflected back and forth between these two mirrors and the output can be obtained from the mirror M2. Next we'll see what is population inversion. The establishment of a situation in which the number of atoms N2 in the excited state E2 is greater than the number of atoms N1 in the ground state E1 is called as population inversion. The process of creating a population inversion is called pumping. The commonly used methods for pumping action are optical pumping, electrical discharge method, direct conversion, inelastic atom-atom collision, and chemical. First, let us see what is meant by optical pumping. In this type, the atoms are excited with the help of photons emitted by an external optical source. The atoms absorb energy from the photons and reach the excited state. This method is used in solid state lasers like ruby laser and Nd:YAG laser. Electrical discharge method is used in gas lasers. Here the electrons are accelerated to very high velocities due to strong electrical field. These accelerated electrons collide with gas atoms and the gas atoms are raised to excited states. Next is direct conversion. The combination of electrons and holes takes place in semiconductors due to the supply of electrical energy. The electrical energy is directly converted into light energy. This is happening in the case of semiconducting lasers like gallium arsenide. Another method is inelastic atom-atom collision. In this type of pumping, a combination of two types of gases, say A and B, are used. Both are having same or nearly excited states. During the first step, A atoms get excited due to collision with accelerated electrons. This excited A atoms now collide with B atoms and B atoms reach the excited state due to gain of energy. So E star or that shows the excited or the electrons having higher energy transfer the energy to A and the A atom goes to the excited state. The excited A atoms transfer their energy to B and B becomes excited. For example, this happens in helium neon laser and carbon dioxide laser. Chemical reactions. So due to chemical reactions, the atoms in the ground state move to the excited state. This is happening in the case of. Now let's see what's the principle of laser. Consider an assembly of more number of excited atoms. When the first excited atom undergoes stimulated emission due to an incident photon, a coherent photon is emitted. Both the incident photon and the emitted photon move in the same direction with same frequency, phase and energy. These two coherent photons induce another two excited atoms to produce four coherent photons, and the four coherent photons produce eight coherent photons due to stimulated emission of another four excited atoms. This process continues as a chain reaction for the emission of more and more number of coherent photons to produce a powerful laser beam. Hence, a laser beam is a powerful one due to production of large number of coherent photons by stimulated emission of excited atoms. This diagram shows the multiplication of photons by stimulated emission. One photon producing two photons, two producing four, and four producing eight, like a chain reaction. Thereby, we get an intense beam of laser ray. Thank you.